Trees were very important for the development of this country. They were used for houses, barns, and for fuel. So the fact that the eastern portion of the country was covered with trees was very helpful for the early economic success of America. Trees still play a vital role in much of the world today. This photo is from Malawi, Africa. But as you know, carbon emissions are leading to rising temperatures and coastal flooding. This is a big concern for all of us. Venice, Italy is pictured here. Is there an easy fix for carbon emissions? I wish it was this simple, but of course it's not. Actually, we all contribute to carbon emissions in some way. While driving your car, each gallon of gasoline you use will result in 20 pounds of carbon dioxide being produced. So it's not only our transportation, but our heating, fuel, and our food consumption that contributes to carbon dioxide being produced. Almost everything we do contributes in some way to the carbon emission problem. However, trees convert carbon dioxide to oxygen. Through the miracle of photosynthesis, trees take carbon dioxide and produce oxygen. Software was developed by the Forest Service to predict tree growth. The tree growth software shown here predicts volume growth and basal area. This tree growth simulator was made accessible as a web tool called the Forest Stand Carbon Simulator. This web app estimates how much carbon trees capture as they grow. So you describe the trees in your particular area. With this website, you enter the number of trees per acre and the simulation length, which varies from 5 to 30 years. So you can get an estimate of how much carbon is captured during this time period. Here we show the results of the simulation. For this particular stand of trees, there were 36,000 pounds of carbon captured by the trees in this 30-year time period. The tree carbon game was developed based on the carbon simulator. This game activity helps illustrate the tremendous role that trees play in capturing carbon. Students are separated into two teams. The teams then select the trees that they think will capture the most carbon. The teams go out into the woods or next to houses or their school and measure the tree diameters within a 33-foot circle. The tree measurements are written down. As an example, for this game we have two teams, Team A and Team B. Team A has selected an area shown, which has two 4-inch diameter trees, two 5-inch diameter trees, an 11-inch and a 14-inch diameter tree. Team B selected an area with a 25-inch diameter tree and an 18-inch diameter tree. So Team A has selected the circular area containing the trees shown on the left, and Team B selected the trees shown on the right. We use a 30-year time period to grow the trees. Over that 30 years, Team A's trees captured 735 pounds of carbon, whereas Team B's trees captured 118 pounds of carbon. Since Team A's trees captured more carbon, Team A would win the game. So let's face it, Kids today spend too much time on their devices. The Tree Carbon game provides a fun way for kids to learn about trees and their contribution to the air we breathe. The game goes beyond the classroom and connects students with the outdoors and lets them interact directly with the trees in their area. Rather than view trees as static parts of their environment, the students get an appreciation of trees' dynamic nature and their contribution to the air we breathe. Polar bears are running, got nowhere to go. Polar bears are running, got nowhere to go. Ice is slowly melting, there goes the snow. Riding my jalopy, burning carbon every block. Riding my jalopy, burning carbon every block. You know as well as me, we're never gonna stop. Carbon blues, stay away from my door. Carbon blues, stay away from my door. Don't you come back, don't come back no more.